Alright, for 5 and 6 down here, not sure why the numbers repeat, but we're going to find the inverse of each function, determine whether the inverse is a function, state the domain and range. This kind of has a lot of pieces. Let's start by finding the inverse. We're going to write this as y equals 25 minus x squared. Okay, then we're going to switch x and y. And then solve for y. I'm going to get rid of that 25 first. So x minus 25 equals negative y squared. Let's get rid of the negative. Divide by negative 1 on both sides. So that becomes negative x plus 25 equals y squared. And then we can take the square root of both sides. Dark blue. Alright, square root here, square root the entire side over here. So then we're left with y equals square root of negative x plus 25. And then we need to write that in function notation. So f to the negative 1 of x equals the square root of negative x plus 25. Alright, that's finding the inverse. Now determine whether the inverse is a function. I'm going to graph to do that. State the domain and range. So if I were to graph this, I would get a square root function shifted to the left, 25, and then reflected. Actually, it's going to be shifted to the right and reflected. You can graph this in the graphing calculator. The way that it's written here, it is a function, but if we were to just graph the original, this one's a little bit easier to graph in your calculator anyway, so just graph the original. You're going to see that you get a quadratic function, reflected, and then shifted up 25. So something like this. And it does not pass a horizontal line test, so the answer is no. The inverse is not a function. And then we were going to state domain and range of the inverse. So our domain of the original is all real numbers, which means our range for the inverse is all real numbers. So from negative infinity to infinity in interval notation. And then our domain of the original, the range of the original is from negative infinity up to 25. So that means our domain is from negative infinity to 25. Alright, on number 6, I'm going to go ahead and let y'all do that one. I'm not going to go through the entire thing. Well, let's look at number 7. So we're going to find the inverse of number 7. S is the length of each side. So we're going to start by rewriting a of s as y. And instead of s, we're going to use an x. Okay, now we switch x and y. And then solve for y. So since all this is in parentheses, I can't do anything with that yet. So I'm going to divide everything by this 2 to get rid of that. So those are inverses, they cancel. Alright, so we've got x divided by 2, or 1/2 x, it's the same thing, is equal to y squared times the square root of 2 plus 1. Alright, now we want to get rid of the square root of 2 plus 1. It's all being multiplied by my y. So we're going to divide by the square root of 2 plus 1 on both sides. So at this point, I've got 1/2 x divided by the square root of 2 plus 1 equals y squared. And we can actually just write that as x over 2 times the square root of 2 plus 1 equals y squared, and then we want to take the square root of both sides to get y by itself. So our final a to the negative 1 of s is equal to the square root of x over 2 times the square root of 2 plus 1. Alright, so that's our inverse. Alright. And I believe it also, this question is missing, but it's asking what the inverse is, what it represents in the problem. If you think about it, when we switched x and y, we were originally solving for this s right here. So the inverse represents the length of each side, or the side length. So this formula right here, the a to the negative 1 of s, represents your side length. Alright, we're graphing the following parent functions and their inverses. So starting with the quadratic equation, there's a quadratic parent function, y equals x squared. So we're going to graph that. If you don't remember how to graph your parent functions, you may want to review that. I'm going to do this fairly quickly. Alright, so there's my quadratic parent function. Alright, the inverse. Remember we switch x and y. And then we're solving for y. So switch x and y. Solve for y. So I'm going to take the square root on both sides. These cancel, so we get y equals the square root of x. So that is our inverse. Alright, now if we were just going to graph it based off the points themselves, we would graph the point 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2, 9, 3, 9, negative 3. This would be our inverse. So this is actually including the positive and negative square root of x. And we also could have just done our horizontal line test on the original function and seen, okay, it crosses twice, so it is not, the inverse is not a function. The original is not one-to-one. It's not one-to-one because it does not pass the horizontal line test. Alright, square root, parent function, y equals the square root of x. Alright, so you get the inverse, we switch x and y, and then solve for y. So I'm going to square both sides to get y by itself. Okay, so parent function for square root looks like this. Oh, that was supposed to be in purple. I apologize. And then our inverse, if we graph it just based off the points, point at 0, 0, there's a point at 1, 1, there's a point at 2, 4, and 3, 9. So it would only look like this. And if we do the horizontal line test on our original purple function, move that up and down, and we notice it does not cross twice. So the answer is yes, it is one-to-one. Okay, let's do the cube root function. Y equals the cube root of x. It graphs a little bit funky, but this looks something like this. Alright, so there's our cube root function, and our inverse ends up being the cubic function. You can do the math and check that. Let's do that in a different color. Alright, and that's also one of our parent functions, so we know what that looks like. And the answer is yes. The original is 1-to-1 because it passes a horizontal line test. All right, our absolute value parent function, y equals the absolute value of x. And I can graph that. Remember, it starts at 0, 0. We have a V shape for absolute value. All right. Now, algebraically, we can't figure out the inverse equation. But I can do my horizontal line test, and I see the answer is no, it's not 1-to-1, which means the inverse is not a function. But if I did want to graph the inverse, just based on the points, I would still have this section here, but then I would also have this section here. And the only way to write that equation is y equals x, and we'd have to restrict our domain where x is greater than or equal to 0. And this, don't stress about, you definitely don't have to memorize this, but I'm just giving you the equation for the inverse in case you wanted to know it. Y equals the negative x, that gives us this bottom part right here, but our x also has to be greater than or equal to 0. So we're only looking at the right sides of these two lines.